little while ago, about a half hour ago, I sent out a PDF of an open response question that I want to talk about today. Hopefully you've had a chance to see it. If you haven't, that's okay. I'm going to put it up on the screen as we begin to talk through it. But before we get started, I want to give you an update on kind of where we stand and what I know, right? And so first of all, with regard to the AP exam, I don't know if you're receiving, let me ask you this. Are you receiving any contacts from AP about updates to the exam? Is anybody getting anything?
Sometimes it'll send me a notification.
Have they given you anything about the specifics of the exam yet?
When you log on to the website, there's like a list of stuff that it tells you about changes, but like nothing specific to like stats, I guess.
Okay. I don't know if they have now started a kind of like this, a classroom video session covering topics. There are a couple of teachers that are doing essentially the same thing as I'm doing right now. I haven't watched any of the videos, and there's a good reason for it, which I'll tell you in just a minute. But I still don't know anything about a date. I read online today that there are apparently going to be more than one date for the at-home exam. They call it an early date and a later date. So I don't know what that means, but as soon as I do, I'll let you know. I also don't know what will happen if we go back to school before the exam date. Let's say we do go back on April 20th, which is our currently scheduled return date. Would we still take the exam just like normal on May 15th? I don't know. Every day I think they're making updates, but I still don't know what happens if we go back to school. Now, for the video sessions, I will send you the link. They are doing a session live, but I think they also record it and post it on YouTube, just like I've been doing. The reason I haven't sent you links to it is that when I talked to you before, I mentioned that they are they're off the tail end of the course, and the videos that they have posted are all related to stuff that have been chopped off and not included in the exam. So you're free to go and watch. I mean, I encourage you, if you're interested, you can go and watch. They're talking about solving problems related to the chi-squared distribution. Not tested on this year's exam, according to their website. So it's material that is still a ways ahead of us, and so we haven't really talked about chi-squared at all. And we still have to talk about a little bit more about inference before we're ready for that. So, but they're posting videos of stuff that's not on, not going to be on the exam. So I can't answer that. If you do go and find your way, there is an AP Google. Not a Google, a YouTube channel dedicated to AP, and you can select topics of any AP course, I think. I will provide you the link, but right now they're showing videos of stuff that aren't covered. Now, the live feed is at exactly the time that we're getting together, 1 p.m. Central. So you're welcome to watch that. But I don't know that it's very useful in terms of getting ready for the exam yet. One other thing is I want to make sure I was clear. And I think I may have misspoke. It was 2 or 3 days ago when we talked about this, and I don't remember what I told you. But the at-home exam will be an open response exam, not multiple choice. And I can't remember if I told you multiple choice or open response. But it's also only 45 minutes. And so in order to cover the material that they want to cover, I can't imagine that the exam questions will be very in-depth, which is different than a normal exam. In addition, they are going to, they posted today or yesterday, I read it today, I think it was actually posted yesterday. They posted that they will be providing sample questions for us to cover. So as they start populating those, I will forward those to you or provide the link for you. My guess is they'll start populating those during our spring break. Now, I don't plan to hold our 1 o'clock meeting during spring break unless you guys just want to. I mean, I'm going to be here. I'm not going anywhere. If you guys want to keep going, I'm fine with that. It would give us more time to get ready, but it is spring break, and so ordinarily we wouldn't be meeting. But that's really up to you guys. We can talk about that somehow later. But I expect they'll be posting sample questions coming up during our spring break. So I will be forwarding those to you or giving you the link when I do get them, whether that's during spring break or not. So I know right now just enough to be dangerous about the AP exam. It's entirely uncertain, just like everything else is right now, honestly. No one in the whole world is ever prepared for something like this, and so we're all scrambling around. Now, I'll go ahead and let you know for tomorrow, I may not be able to make it for our 1 o'clock session tomorrow, simply because we have been requested by the state to provide a lot of documentation for what we've covered these last 2 weeks, and even going back to the first 2 NTI days, which means I have to go back to school and dig through my folders there. But it may be that I'm just covered up trying to get all of that stuff put together and may not have time. I will let you know late morning tomorrow whether I'll be there or not. But if I'm not able to, it's not a bad sign. It's just Mr. Spears wanted us to get all this stuff together by the end of the day tomorrow. So I'm kind of on a short fuse, and I don't know I can get all of it done and still be here by 1. So, that being said, it's not anything gone wrong. There's not anything crazy going on. It's just that I've got to put together a lot of records, and it'll take a while to get all that done. Okay. All right. So let's get started. What I want to do today is give you an introduction to an open response question that is typical of material from this unit. And after we're done here, I've got 2 more to send to you that I think are, again, pretty typical. They're certainly typical based on what we have discussed. There are plenty of these type questions available, and I just picked 2 of them. We'll go through this one example, and I will let you have those others after we're done here. Okay. So let me, for those who haven't read the question, let me put that up on the screen now. And let's see. Well, there it is. Let me zoom in a little bit so you can see that a little bit better. Big Town Fisheries stocked a new lake with 2,000 fish of various sizes. The distribution of fish links is approximately normal. Now, how they know that, we don't know, but they know it. So that's a given. We can take that one and use it. We'll use it to our advantage here for first part at least. Big Town Fisheries claims that the mean length of the fish is 8 inches. If the claim is true, which of the following would be more likely? A random sample of 15 fish having a mean length greater than 10, or a random sample of 50 having a mean length greater than 10? So I'll open that up to the group. Anybody want to throw out an answer to that one yet?
Would it be the first one, because the standard deviation would be greater?
That's exactly it. Yep, a sample size of 15 is going to have a wider curve than a sample size of 50, and because 10 is pretty far from the mean of 8, the tail area for the smaller sample is going to be a little bit larger than the tail area for the larger sample. So let me come back to the camera here, and I'll try to illustrate that on the board behind me. Let's see. So now, first of all, question is we have to answer is, does the 10% condition apply here? I think the way the question is worded, there's 2,000 fish that are added. So our sample size of either 15 or 50 is well less than 10%. So the 10% condition is met, so we don't have to worry about that. But if we did sketch the distribution of the two samples, first of all, what shape is it? The sampling distributions will have what shape?
Bell-shaped, because they're normally
yeah, they'll be normally shaped, a bell-shaped, single-peaked, because the population from whence they came is normally distributed. So the sampling distribution of the sample means will be normally distributed as well. What will be the center of the two sampling distributions? Well, the center is going to be the population mean, which is 8. So the population mean is 8. So both of the sampling distributions are going to be centered at 8 as well. So one of them will look something like that, and the other one will look something like that, except this peak here should be centered over 8. And we're looking at a fish size of 10 inches, which is to the right of the mean. Now, we don't know what the standard deviation is yet, but we know that when I divide the standard deviation by n, this curve is for n equals 15. The tall skinny curve is for n equals 50. And so I don't know how well you'll be able to see this, but the area under the curve to the right of 10 for the sample size of 15 is this big area here. The area under the curve for the sample size of 50 is just this smaller area here. Okay, so the pink area is certainly going to be bigger. So the probability of getting a sample of 10, I'm sorry, a sample of 15 whose mean length is greater than 10 is going to be larger for the sample size that is numerically smaller, because it's in the denominator here, and the sample size is in the denominator. So the smaller number in the denominator means the larger, you get a larger value. Okay. So to answer the first question, the probability of getting a sample size where the mean is greater than 10 is more likely to occur with the smaller sample than the larger sample. Okay. So let's go back. Let me put that back on the screen. There we go. Okay, so for part B, suppose the standard deviation for the sample size of 50. Now let's read that carefully. Suppose the standard deviation of the sampling distribution of the sample mean for the random sample of size 50 is 0.3 inches. If the mean length is 8, use the normal distribution to compute the probability that a random sample of 50 fish will have a mean length less than 7.5. Okay, so the trick here is understanding exactly which standard deviation we're talking about here. And we're talking about sigma of the sampling mean. So we don't have to divide that by the square root of 50. That's already built into that 0.3. So we can use the population mean and the and this particular standard deviation to go ahead and calculate our length. So let me go back to bring back the camera here. And I'll show you. You can do this calculation. I'll do it. I'll put up the first few steps here, but then again, I will also show you on the calculator just to keep our memories fresh on how to use normal CDF. But here we want we have a just to be clear, the mean of X bar is the mean of the population, which is 8 inches. Sigma of X bar is given to be 0.3 inches. So we want the probability that X is less than 7.5, which is the same thing as the probability of a z-score. We want to calculate a z-score. Well, we can use 7.5 minus 8 divided by 0.3. And that value is negative 1.67. Negative 1.67. And then we can take that, so we want a z less than negative 1.67. And we can look that up on table A. Or we can get to it directly using calculator. So let me put that up here. real quick. Okay, so we want the normal CDF because we want a value less than 7.5. So we'll pick choice 2. The lower limit here is a really, really small negative number, or really, really big negative number, I guess is the best way to say it. And the upper limit is going to be 7.5. The mean is going to be 8 and standard deviation of 0.3. So let me ask the question before we punch the button here. What do we expect? Do we expect a big number or a pretty small number here? Well, just looking at the mean is 8, and 7.5 is more than 1 standard deviation. It's even almost 2 standard deviations away. And remember, this is the sample distribution. So, and it's a sample size of 50. So it's a pretty tall, skinny distribution. So being approximately 2 standard deviations away, we're going to expect a pretty small number here. And so let's see what we get. Okay, so we get 0.047, 0.048. So 4.8% chance. I think if you look it up in table A, well, I don't even have to think. I can look it up here real quick. Table A, negative 1.67. 0.0475. So just a minor difference in the values there. So about 5%, which is a pretty unusual occurrence here. Okay. And then let's see, part C. Part C says, let me pull it up now. Part C says, suppose the distribution was non-normal. Okay, forget everything that we've talked about so far about the shape of the distribution, but the mean and standard deviation are the same. Would it still be appropriate to use the normal distribution to compute the probability in part B? Justify your answer. Okay, so what do we think? Can we use the normal approximation here to figure out the probability in part B, even though the shape of the population distribution is not normal? Any idea?
Yeah.
Okay, why? What's that?
The central limit theorem.
Yeah, the central limits theorem says that if our sample size is large enough, and the sampling distribution of the sample mean becomes approximately normal. And the kind of the thumb rule I threw out there yesterday, and I don't know if your textbook uses the number 30. I think it does somewhere. I haven't reread the chapter yet, but I think it says somewhere that we're looking for sample sizes of 30 or more to be sure. And 50 is certainly larger than 30. So that's large enough to pull the central limit card and play it and say, okay, I don't care what the distribution, population distribution looks like. The the sampling distribution of the sample means is going to be normally distributed or approximately normal. And so we can use the normal approximation there. So now let me ask you this. If the question had been centered around what's the proportion of fish that have a mean length less than 7.5? In other words, we sample 50 and we count the proportion. Can we go down the same path with here if we were counting proportions? All right. The answer is not necessarily. There's a different criteria that has to be met to consider the sampling distribution of a sample proportion to be normally distributed. The sample size has nothing to do with it when we're talking about sample proportions. The criteria for a sample proportion would be like a sample proportion like p hat would be n times p has to be greater than 10, and n times 1 minus p has to be greater than 10. And so we would have to know something about the population proportion. But the good news is with a sample of 50, unless those proportions are really, really small, there's a good chance that that product is going to be 10, but you still have to, going to be greater than 10. So you still have to compute it though. We can't just say because we're taking 50 fish, I know that it's going to be normally distributed. So keep in your mind the shape of the sampling distribution of a sample proportion is determined differently than the shape of the sampling distribution of sample means. The sample means shape is either based on the parent population, or the central limit theorem covers us if the sample is large. For the sampling distribution of a sample proportion, we have to calculate that n times p and n times 1 minus p. Both of those products have to be greater than 10 before we're sure that it's normally distributed. Even if the parent population is normally distributed, you don't get to pass go and collect $200 with sampling proportions if the shape of the parent population is normal. Okay, you still have to calculate that n times p and n times 1 minus p. Okay. Okay, so that's it. That's big town fisheries and the use of the sampling proportion and the sample distribution. We've covered what happens when you change sample sizes from a small one, n equals 15, to a large one, n equals 50. And you can see that, well, I had the shape up there. And we've talked about how does the central limit theorem come in and help us with large samples. So that's a pretty good summary in terms of open response questions that we've covered. Like I said, I'll send you 2 more. And I will, since I can't be sure whether I'll be available tomorrow, I'm just going to hold these off to be due until we get back from spring break. So if you get a chance to do them, go ahead. That would be great, especially while it's fresh on your mind. But I'm not gonna ask you to submit them because I don't know that I'm gonna be here too much tomorrow. So we'll just talk about it when we get back after spring break. I'll have something else to share tomorrow if we can get together. Anybody have any last questions before we sign off?
I have a question about the number 60 from yesterday.
Number 60. Okay, let me get my book.
The lightning strike
This
question.
is the lightning question. Okay.
It's just on part A for now because that's what I've looked at so far. But
Yep.
I don't know what n is to try to find the standard deviation for the new standard deviation.
The sample size?
Yeah.
Isn't it 10?
It's, let's see, I'm trying to reread the question here. Somewhere it uses 10. The NLDN uses automatic sensors to watch for lightning in a random sample of 10 1 square kilometer plots. So, so the sample size here would be 10.
Okay. And then on part C, when it says when they take a random sample of n equals 50 square kilometers, is that just,
Yeah.
is that one 50 square kilometer patch?
No, that one means 50. Yeah, it's 50 1 square kilometer plots. So it's 50 different plots, each of which are 1 square kilometer.
Okay.
Okay. Yeah, that wording is a little unclear. I see how you could get that. It's not a single plot of 50 square kilometers. It's 50 different ones that are 1 square kilometer each. So
Okay.
either way, it's still 50 square kilometers, but it's broken up into 50 different pieces. Okay. All right. Does that help?
Yeah.
All righty. Any other questions? All right, gang. It's good to see your faces. I don't know how it makes you feel, but it sure makes me feel good to see you guys. And I know that some of the others who aren't joining at 1 o'clock, I know several of them are watching the videos. One of the advantages of posting it on YouTube is I get to see how many times it's the videos are accessed. I can see that several of you are watching offline, so that's fine. And that's why I record this, is to help everybody out. And I know we can't all be available at 1. So y'all hang in there. Have a great spring break. Don't be a stranger though. If you want to get together over spring break, let me know. I'll be, like I said, I'm going to be here pretty soon. I'm going to be bored of looking at Romano's silly face every day for day after day after day. I'm going to be wanting to see some new faces. So, anyway, y'all have a great spring break, and I'll see you on the 13th if I don't see you before. All right? Y'all take care.